I'd like to now introduce Erika Kamptner. Erika has also been a regular player around the table in many of these discussions, and she'll be representing our New York City Department of Information Technology and Telecommunications, really a major player here in New York City.
Hi, good morning. So I work with the New York City's kind of IT department, specifically our group is called the Data Management and Integration Division. And what our team of analysts, developers, geospatial experts, what we work on a lot is helping with data acquisition projects, data coordination across city agencies. And we're kind of a central hub of GIS for data sets that all the agencies rely on. So like Alan, I'm starting with this beautiful picture. So I really like starting with this picture. It's a great example of the complexity of the state of underground in New York City. Under 6,000 miles of asphalt in New York City, we have water, sewer, telecom, steam in Manhattan, and then in addition to that, we have MTA, Long Island Rail. It's a complex system, and coming into this project where I'm going to talk about the 3D Underground infrastructure project, I don't come from a utility engineering background, and so I was like, oh, mapping underground utility, how hard can that be? And this is kind of the state of what we're dealing with. It's not easy. It's very complex and has a lot of challenges. So briefly, some background on the project. In 2017, the mayor's office reached out to DOITT, our team, to develop a proof of concept, a model using city agency data sets for underground infrastructure. Some very high-level goals of this project were really, can we develop the technical relationships with the data providers? This wasn't just having meetings, having phone calls with, can we use your data? Okay. It was going to DEP, sitting down with the data editors and understanding how does their source information, which is sometimes a photograph or PDF, and how does that translate into a digital product that they use. Second, understanding the city's ability to actually integrate this underground infrastructure data. And then finally, identify opportunities for enhancing the quality of underground data. As mentioned earlier, coming into this project, there were known data quality issues, so we wanted to see areas that we could help improve that in the future. And the project area was Thompson Avenue in Long Island City in Queens. So it's a fairly small project area, but we were able to pull in data sets from different agencies into that area. This project also highlighted some interagency data challenges that already exist and helped us kind of identify what those challenges were. One, as mentioned a lot this morning, is the challenge of creating a common operating picture. This isn't just a challenge for underground infrastructure, but we see it often with one of our most popular data sets, the building footprint data model. And that's an issue that our agency is trying to address, but it's becoming a challenge for everyone to be on the same page no matter what data sets they're working with. Second, data sharing in general can be overly complicated, and not often, especially in emergency situations, are the agencies getting that data in a timely fashion. DOITT has a couple ways of sharing data. We have legacy systems, Data Bridge and Data Share, which are pretty complex, where agencies can connect through firewall connections and get access to databases. But those projects for sharing, access to a database table can take months or even years to implement. So they're not timely. Third, this is an issue with underground and for non-underground data sets, but agencies don't know what they don't know. A lot of times agencies say, ask another agency, share all your data with me, and a lot of times, there's no kind of common catalog of understanding what data sets are available for agencies to use. And lastly, this is a major issue that also is important to the 3D underground model, but the data, understanding the data and its fitness of use. Specifically with New York City, all data sets are created as a byproduct of an agency's business need. And an example being the sewer and water network data. That data was digitized in a 2D network model, but a lot of agencies want to use that for understanding the exact location of a pipe or for emergency response or planning initiatives. But we need to make sure that agencies understand that's not how that data was created, and there's known inaccuracies in that model. So making sure agencies know what the data was created for and its intended use so that they use it properly in the future. As mentioned, mapping underground infrastructure in New York City hasn't been new, but there's been barriers to creating a consolidated 3D underground model, mostly political reasons. First major hurdle is security concerns. Several agencies and utility providers are concerned with data getting into the wrong hands, especially in a post-9/11 environment. Second, some agencies are more private utility companies don't see the incentive to share. Maybe that's because they haven't seen the value of creating a consolidated view. Third, again, this is probably more aligned with private entities, but a lot of data providers are concerned about liability associated with disclosing that infrastructure information. Especially in New York City, private entities sharing, location of their telecom networks may highlight inequality throughout the 5 boroughs, which is a big concern in New York City in general. So that kind of we've seen a little bit of pushback on that front. Disclosure of proprietary information to competitors, again, related to kind of telecom, not wanting to share their location information with others. And then finally, this has been mentioned as a barrier. I don't see technology as really a barrier in the sense that it's 2019. We certainly have the technology to implement something like this. But anyone that's worked within the public sector understand that sometimes attaining that technology is the biggest hurdle. So specifically with the city, the procurement process can be kind of holding us back in moving forward with this. So for the POC, we worked with 5 agencies, selecting from environmental protection, transportation, design and construction, Department of Buildings, and DOITT. So from the Department of Environmental Protection, we have water mains and all the associated features. We also have the sewer network. The DOITT manages franchisee agreements, so we were able to obtain Verizon conduit. Department of Design Construction, they have as-built and borehole technical reports. The Department of Building also provided borehole technical reports. And then Department of Transportation providing street-level projects and street-level ratings that they manage. So from a very high-level bird's-eye view of this POC, this is kind of the general workflow where agencies would be able to provide data for this POC in an S3 bucket. They could provide it in any format that they generated. So some create these data sets in geospatial format, some in CAD format. Then we ran an ETL tool called FME that would transform that data, digitize it into a 3D model, normalize it, and then fit it into an OGC muddy standard. And then third, write it directly to a PostGIS database. This was a very important aspect in that the data model needed to be interoperable with different city agency software or workflows that they currently use. So we see this as anyone using Esri or CAD systems or even data analytics using like a Tableau kind of software could access this data in the common operating or common interoperable format. And then lastly, for the PSC, they wanted to visualize it in a 3D model if they were the web application. I have just a brief video showing what that looks like. So this is a kind of web application showing using ArcGIS Online, just kind of highlighting all the data layers for the project area. So we have a 2D view, but we can also see 3D, how it's digitized. People could zoom in get attribute information by clicking on a feature. We also digitize the soil boring data from reports. So this is from Department of Design and Construction for soil boring. We can get a core sample of what that would look like. For this model, we just created kind of an example before, but this could be in a 3D voxel layer as well. So what I see are the next steps for a citywide 3D underground model. It's very important that we include data domain owners and end users in the entire development process. I myself am not an expert in underground utility, and as DOITT being the kind of creator of this model, we need to ensure that DEP, DOT, all the stakeholders are included in discussions, making sure that we represent their assets properly in the model. It's very important that we leverage existing data investments. New York City recently invested in cyclomedia terrestrial LiDAR data. And this is the picture on the right. And leveraging those existing systems can also help improve overall data quality. We use cyclomedia to kind of verify street level accuracy. So we see a hydrant in our model. Does that line up with the hydrant in actual real world? Citywide standards for data and metadata. As I mentioned, we got 4 whole technical reports from Department of Design and Construction and Department of Building. Each agency delivered those in PDF format in about a dozen different formats per agency. So for common data sets, there should be standards associated with those. Feature level metadata, this ties back to the fitness of use. End users need to understand the inherent data quality or any potential areas of inaccuracy or with each feature. And then platform independence, making sure all end users are able to access this through whatever software or workflow is different.
Thank you, Erika. We have a ton of questions for you, so I'm only going to be able to, I'm only going to ask a couple very quick ones. So if your question didn't get answered, please see Erika during the break. So one quick question, was the web tool that you showed accessible to the public? No. Do you think it would be beneficial for each of the stakeholders in the subsurface arena to have some type of ambassador to help negotiate and advocate, I guess?
Yeah, certainly. I think it's mostly convincing upper management to sign on. A lot of that is tied to political obligations, but I mean, everyone that worked on this project is definitely invested, and they just need to kind of work their way up to upper management.
All right, one last quick question. Do you have a vision of how 5G technology might change all of this? All right, well, thank you very much. So.